Here I am going to explain independent-dependent probability. So here we go. So let me get my handy dandy pointer here. So when you are talking about an outcome of one event that does not affect a second event, we say that the events are independent. And another thing we're going to find out is that is with replacement. So if I took a marble out of the bag and replaced it before drawing another one, that would be an independent event. Dependent is when the outcome of one event affects or makes a difference on the second one. And that is without replacement, as we will also find. So there's going to be a couple scenarios we're going to talk about in this video. So with replacement, without replacement. So if I took a card out of a deck of cards, did not return it, that affects the outcome of my next pull, my next selection of the card, if you will. Alright, so let's look. What is the probability of multiple events? So we're going to classify each of one of these as dependent or independent. So if you're paying attention, try to get the answer before I show you. So if I spin a spinner and select a marble from a bag that contains marbles of different colors, are those events dependent or independent? Does one affect the other? Well, they are independent because it does not affect each other at all. They don't affect each other. So what about scenario B? If I select a marble from a bag that contains marbles of two colors, put the marbles aside and select a second marble. Okay, that is dependent because I did not replace it. So it's going to affect the outcome. Selecting one and not returning it affects the outcome of my next probability or my next picking a marble. So let's look at some more. An expo marker is picked at random from a box and then replaced. A second marker is then grabbed at random. So what happens here? Did I replace it? Yes, I did, so it is independent. So two dice are rolled at the same time. So does one die have the effect, does one die have an effect on the other die? So if I roll a 3 on one die, does that mean I'm going to roll a 3 on the other? No, they're independent. They don't affect each other. What about if an ace is picked from a deck of cards? Without replacing it, a jack is then picked from the deck of cards. Okay, so I did not replace it, so my outcomes are changed, so those are dependent. So if I have independent events, all I do is take the probability of A, and we use the word and there, and multiply it by the probability of B. So if I told you probability of A was 1/2 and B was 1/3, so how do I know what the probability of A and B is? You just multiply those together, so the probability is 1/6. And remember, probability is a fraction or a decimal between 0 and 1, inclusive to the 0 and 1. So let's try an example here. A box contains 20 red marbles, 30 blue marbles. A second box contains 10 white marbles and 47 black marbles. If you choose one marble from each box without looking, what is the probability that you get a blue marble and a black marble? Okay, so the first one, how many total marbles are there? There's 50, so that would have to be our denominator. And it says, what is the probability of getting a blue marker? Well, there are 30 blue, so that would be 30 over 50. And the next scenario, I have 10 and 47, so that's 57. How many of them are black? 47. So I'm going to take those two probabilities here, 30 over 50 and 47 over 57, and multiply them together. And we simplify, and you could get a percentage as well. Remember, you take that and multiply it by 100 to get your percent. Okay, so next scenario, well, let's see what's up. Independent events. Suppose you spin each of these two spinners. What is the probability of spinning an even number and a vowel? Okay, so they're two different spinners, so one's not going to affect the other. So what's the probability of spinning an even number? Well, there's 1, 2, 3, 4, 5, 6. Of those 6, 3 are even. So 3 out of 6 are 1/2. Vowels. We've got 1, 2, 3, 4, 5 possible outcomes. How many of those are vowels? And we see that 1 out of 5. So what's the probability of doing the spinning a spinner? What is the probability of spinning an even number and a vowel? You take those two probabilities and multiply them together. That's it. So let's talk about dependent. There's a little bit of difference here. It's not a lot, but if you remember this, it will go far with you. So how can that change? So what happens is the dependent denominator changes. I'm still going to do multiply probability of A times probability of B. However, this probability of B is going to be a little bit different. So let's look at an example. So there are 6 black pens and 8 blue pens in a jar. If you take a pen without looking and then take another pen without replacing the first, so there's my keyword, without replacing the first, what is the probability you will get 2 black pens? Okay, so first of all, how many total pens are there? Well, you get 14 total. Of those 14, how many are 6? How many are black? 6. So there's 6 out of 14, and I did not replace it. So what happens? If I didn't replace the 14 pens, if I took one away and don't replace it, is there still 14 outcomes? Are there still 14 pens in there if I took one away? No. That now becomes 13. And if I selected a black pen the first time, do I have 6 black pens in there? No. So your second probability, there's 13 pens left and there's 5 black ones. So it's 5 out of 13. Therefore, you multiply those two together. And here is a question again: what changes in probability and probability A and B in regards to independent versus dependent? Independent, they don't change. Your denominator does not change. Dependent, you will notice that your denominator decreases by 1. So let's look at this example. So are these independent or dependent events? Tossing 2 die and getting a 6 on both of them. What do you think that one is? Tossing 2 die and getting a 6 on both of them. They are independent. Okay. What if you have a bag of marbles? There's 3 blue, 5 white, and 12 red. You choose one marble out of the bag, look at it, and then put it back. Okay, you put it back so it's with replacement. So that is, again, independent. Okay, now I've got a basket of socks, and I don't know why these probabilities, they always use in marbles or socks or something, or cards. So you find the probability of pulling out a black sock, and it's matching black sock without putting the first socks back. So you reached in, you pulled out a black sock, and then you didn't replace it, and you pulled out another black one. Okay, if you didn't replace it, they have to be dependent. And then what if you pick a letter Q from a bag containing all the letters of the alphabet? You do not put the Q back in the bag, therefore you pick another tile. So what is the probability of getting 2 Qs? No, you can't do that. It's 0, but they are dependent events. So here's kind of a different look at this. So what's the probability of getting a 6 on a die and not a 5? So of a die, there's 6 sides, so that would be your denominator. How many are 6s? 1, right? So I get 1/6 for my first probability A. Probability B is not 5. So same on a die that has 6 sides, how many sides are not 5? Well, you should have said 5 of those 6, because there's only one side that is. So that not 5 can throw a little bit of a loop in there for you. You multiply those together, and that's your probability. So probability of Q and then getting another Q, all the letters of the alphabet are in the bag at one time, and you don't replace the letter. So the probability of Q, there's 1 Q out of 26 choices in the alphabet. If I don't replace that Q, there's 0 chance of me getting another Q out of 25 that remain. Notice the sample space decreases by 1 in your denominator. Multiplying those together, so it's a 0 probability. So that is independent and dependent